Hi, everyone. I'm Christal Niederer. I am a senior biologist for Creekside Science, and I'm excited to talk to you about my favorite project. We're preventing extinction of San Mateo Thornmint. This is an annual forb in the mint family. It's listed as federal and state endangered and a CMPS 1B1, and it only grows in serpentine vertisols on the San Francisco Peninsula. It's little. There's a small one there by my finger, and it's in flower, and one up at the top of the screen that's vegetative. They can grow up to maybe 10 centimeters tall. I have seen some larger, but usually they're much shorter than even 10 centimeters. When we started the project, we were working with this recovery plan, and it called for 5 self-sustaining populations of at least 2,000 individuals each to downlist. And this has been amended since. But at this point, when we started, there was only one extant population within this relatively small historic range, again, on the San Francisco Peninsula. And that one extant population was at Edgewood Natural Preserve, which is part of the San Mateo County Park system. Bruce Pavlik and Eric Esplund had done a project with this in 1994, and they had documented more than 53,000 individuals. When we started in 2007, there were only 499, and we looked very carefully. And then the next year, only half that, 249, occupying 24 square meters. So this was clearly a site and an entire species in decline. The actual site has a bunch of threats, invasive grass and its associated thatch being the main one. Italian ryegrass is the main grass there. There are other weeds coming in there. The hydrology's been altered. There's a road upslope that has a fairly new V ditch that's sort of diverting and sort of a natural sheet flow away from the habitat and into culverts. There's a downhill migration that was documented by Bruce Pavlik. So seems like the seeds are kind of rolling downhill and the plants are moving down toward the edge of the grassland and toward chaparral and woodland where they would not persist. If all this wasn't enough, about 2015, we started seeing a dodder blowing up on the site. And you can see at the top picture there, the orange mats of this parasitic plant. And down below, it's just winding around the individual thornmint, taking nutrients out of this poor little guy. So even if we didn't have all those threats, just having a small single occurrence makes this very vulnerable. I also thought it was interesting that there's seed loss in cracks. So I mentioned that it only grows in serpentine vertisols, and vertisols are those real thick clay soils, fairly moist in spring, but then they really start to dry out and develop these big cracks in the summertime. We actually collected some data and we came up with point intercept, 24% of our hits were cracks, and these are big cracks. I've put rake handles down these things. I've seen rattlesnakes disappear into these cracks, which is really comforting to think that your site might have 24% hidden rattlesnake cover. But anyway, seeds are getting lost down there. So our idea was to start experimenting on a small scale and then start scaling up those successful treatments. Just really trying to be careful, working around spots that were occupied, being very clear with where people were allowed to work. And these were our initial results, where we just seeded without any treatment. We had some plants coming in, but where we did treatments before seeding, we had much better results. So we either hand weeded, we scraped, or did a combination there. You can see with those overlapping error bars that those 3 treatments are actually pretty similar. The scraping was actually a lot easier to implement, and so we just stuck with that and ran with it. So basically, we're letting things green up. We're getting that initial germination, and then scraping away that top layer of soil, maybe an inch or less, with a hand tool here in McLeod. just trying to remove competitors. Basically, you're removing the non-native or the annual plants that are there. Largely, it's non-native annual grass. We do have some native annual forbs in there, and they will be negatively impacted by that. But overall, we're focusing on a rare plant, not the common annual forbs. So that's just sort of a cost of doing this. Then you have this nice prepared kind of bed for seeding. We've been putting in usually 500 seeds per square meter. Also later in the season, we'll do some string cutting. You can see a bunch of odd polygons in here. Basically, I'm trying to avoid string cutting the Thornmint because that would be bad. So these lines are basically our experimental plots, and so those have Thornmint in them. So that's great. We're getting down the grasses surrounding the occupied area. We're creating a better buffer, but then the areas that are actually occupied with Thornmint are still grassy. And so that can be a problem. You have a lot more limited options where you actually have the plant. We have tried to do a little bit of this by hand. You can imagine it doesn't scale up very well. So last year we started a Graminicide trial, which is using a grass-specific herbicide, and theoretically the Thornmint should not be affected by that. We think that might be the only real management option to scale up. And our initial results were pretty good. The sprayed and the unsprayed were coming out very similar. We're really tiptoeing around this. We only did 15 square meter plots. We want to make sure that we're careful to not impact too much, that we would just do this very slowly and see if it's working for us. We created an adaptive management plan in 2010, and we increased the minimum number of individuals to 5,000. It was 2,000 in that original recovery plan, and that was kind of boilerplate language that they were using throughout. The concern was, we had observed and Bruce Pavlik had documented, sometimes more than 1,000 plants per square meter. And so I wanted to make sure that, nobody walked up and counted 2,000 plants in 2 square meters and, checked off a box and said, this is fine. So I wanted to raise that and include an area occupancy goal, and also some vegetation goals. We want to make sure we had at least 20% bare ground and no more than 30% cover of non-native plants and thatch. We've had a seed increase program going on the whole time. We started out with partnering with the UC Botanical Garden. Holly Forbes, who I believe is presenting later in this session, got us started, figured out the protocols, and you've really got this program running. And then since it's been transferred over to us, we've been doing this in-house at the Creekside Science Conservation Nursery. So we've had a lot of seeds to play with. That's been great. So I want to talk a bit about our progress. I'll just look at the original site here. On the left side, we have the untreated plots. So this is areas that does not include any of our experiments, none of our seeding. And so bottom line is it's just gone down. So it's gone from, that 499 we were so concerned about down to 28 in 2017. I do have data for the more recent 4 years with 44 individuals being the highest. So it's in trouble. It's tanking if we hadn't done something. But we did do something. So we seeded, when we look at the site, including our experimental seeding plots, that first year seeding, we were up over 3,000. We're super excited. Second year, we're hoping to double that maybe, and, just barely got up a little bit more. And then, funding ran out, the project kind of fizzled. We were still able to monitor, and we were just monitoring this big decline down to 600 in, I guess that's 2014, which was just, we basically lost all of our gains. We're about where we started. So we rallied, got some more funding together and started seeding again, and, got on the right trajectory, about doubled it that next year, and then about tripled it the year after that. And then, that next year we're thinking we're gonna, see another huge bump, and it just tanked again. So that original site is just, it's just not in good shape. It's weedy, it's dry, it's got dodder. We really decided we needed to really focus on other spots. And, you know, we'd been looking at different sites, looking at their soils, vegetative associates, and having high bare ground. And we actually have seeded now at 5 introduction sites. And what do we find when we look? We have found basically that the numbers have just really started to increase once we had additional sites to work with. So we got up to 4 sites total. By 2017, we're at 7,500 plants, you know, added another site, we're up at 19,000. You know, our peak was when we have 6 sites, we're close to 45,000 plants. That's just so far beyond where we started. We're just so excited about those numbers. It just feels so much more resilient. We had a decrease this last year. We had obviously that exceptional drought and the plants took a hit. They're still above where they were in 2019. So we're not panicking, but we know that we do need to think about, you know, climate change and droughts and things like that. So as we're aiming toward self-sustaining populations, you know, we are tracking these cohorts of what we've planted. So when we plant a plot, we put the seeds in once at the, you know, at the beginning, and we do not add seeds after in that spot. So we're tracking these spots. So this red line, for example, at the bottom, you know, has been fairly stable. We do start seeing some increases. So those plants are doing that on their own. That's all passive recruitment. You know, this orange line, wow, what a champion, great cohort. You know, really all of this is all on its own. This is passive recruitment. We do see a decrease by 2019, but then a huge jump in 2020. And even with that decrease in 2021 with the drought, it's still way above where it started in 2017. You know, and we're seeing other cohorts acting similarly, and one even going up when everything's going down in the drought. So we, you know, we have a couple sites that look like this that, you know, do have passive recruitment that look like they're leaning toward being self-sustaining. And then we have a couple sites, you know, that look like that, which do not look good. So we just, you know, when we're not adding seeds, they're just declining each cohort. So that is not great. We did make site retention goals in that adaptive management program. We don't want to give up on them too soon. You know, the weather in California is different every year. Things respond differently every year. The different sites respond differently depending on whether they're toward the wetter or the drier side, et cetera. So we don't want to give up too soon, but we want to know when to say when. And we do want to make sure that the sites are at least as successful as that original site was. And that original site, or excuse me, at least half as successful as the original site. Well, the original site is terrible. This is the red line here, and it's, you know, it's been underperforming all these sites for quite a while. Even that site number 5 that I just showed you that was not doing that well is still way up here. The total numbers are decent. So basically, in conclusion, this species would be nearly extinct if we hadn't taken on this project. And our newly seeded sites are performing a lot better than the original. So we're so glad that we quit putting so many resources into a site that just needed more help than we could give it. We don't really consider any of those self-sustaining yet, but some of them are in a really good trajectory. So we're feeling pretty good. We do really want to state that these long time frames are sometimes needed before you can really see those successes scaling up. You know, it took us about 10 years before we really started seeing those big bumps in numbers and sites. And I think it's so important for, you know, us as practitioners and regulators and funders to know that we really need to think about long time frames sometimes to be successful. We've had a lot of partners on this project. Everyone's important. We needed everybody to get this far, but I do want to give a special shout out to the Friends of Edgewood. They've just really been tireless champions of this project, of this species, and we just really appreciate everything that they've done. And that's it. I hope to hear some questions from people when it is the appropriate time. So thanks very much. Bye-bye.